it's something that's less studied, is solar radiation modification. So it was suggested by Paul Crutzen in 2006. He was a chemistry Nobel laureate who was one of the discoverers of the ozone hole. And basically, what is it? It's basically the idea that you inject sulfate aerosols into the stratosphere, which is the atmospheric layer above the one that we live in. When it starts at 20 kilometers altitude. And the reason that you want to inject these aerosols is to basically reflect sunlight to cool the earth. That's the idea. You want to put it in the upper atmosphere and not in the lower atmosphere, because if you put them in the lower atmosphere, they settle within days. Put them in the upper atmosphere, it lasts more than a year. So you have to do much less of it. It's much cheaper. We know that it works because we've seen it in volcanic eruptions. Interesting thing is that from a global perspective, it's very cheap, right? It really will not cost much to do it. However, it can only be done by large countries with aerospace capability because it requires building a fleet of large cargo planes that can reach 20 kilometers altitude. Such planes do not currently exist. There's been no reason to build them. So we have spy planes which go that high. And we have big cargo planes which fly low, right? But we don't have big planes that can take thousands of tons of sulfur dioxide or sulfuric acid and release it high up. But it can be done, and there are people who are at least thinking about the concept of how to engineer such planes. Yeah. So let's just think about a little bit about the economics. If we think that, if we believe these estimates about, those from the panel data estimates, let's say maybe 3% decline for a degree of warming, that amounts to $90 billion annually. If you go to the US, you find a much smaller effect, and that translates to about $75 billion. So next. So looking at those orders of magnitude, we're talking about something which is of the order of, 0.5% or 1% of global GDP per degree of warming. And that's about the order of $1 trillion, right? So these things are completely different orders of magnitude. So if that's all there was to it, next. If that's all there was to it, then clearly SRM is wonderful. But obviously, SRM has risks. You're going to be doing something which is going to cool the earth. It changes the global climate. There are model risks, which include ozone loss and uneven drying and wetting. The ozone loss problem is quantitatively small, so it's not really an important risk. Next. So one thing is that the world has got wetter as a result of warming, and it's projected to get more wetter, right, with more extremes. But if you reverse some of this warming, what you'll get is the world won't get as wet as it would otherwise have got, right? But you're also changing the climate system. So it's not the equivalent of not putting the carbon dioxide in to begin with. And you could have more drying. You could have, overcompensation, so to speak, in terms of rainfall in some areas. And that's probably the biggest risk that people are worried about. Next. However, current climate models suggest that that's not likely, provided aerosols are injected evenly in both northern and southern hemispheres. So it's very different from observing the natural experiments that we saw, which are uncontrolled, and engineering this. Next. So something about the politics. There's been strong resistance to SRM, to even talk about SRM, or to do research on SRM from environmental groups in Europe and North America. And probably because, in my view, it's because the adverse consequences of warming still seem to be in the future, right? Unlike what they are if you live in Delhi, they're not in the future, they've arrived. Next. And one of the fears expressed by such groups is that if you did this and you cooled the earth a little bit, then there would be less of an incentive to do mitigation, which you have to do anyway, right? Because this is not a solution to the problem. All it does is it temporarily, it's like an adaptation at a global scale. It just temporarily protects you. And it's been suggested by Marty Weitzman initially that SRM has a free driver problem as opposed to a free rider problem. And what he means by that is that because it's so cheap to do, it's conceivable that it could be done unilaterally by a single country, which might be bad for other countries. Next. So there's been quite a bit of theoretical work on this. This is just one paper. And what they show in their model here is that, so you might think that, okay, if a country unilaterally deploys SRM, that might give incentives to other countries not to mitigate because the Earth is cooler, so you don't need to spend a lot of money mitigating. But on the other hand, if countries have heterogeneous perceptions about riskiness and cost-benefit analyses of SRM, then it can have the opposite effect as well, in the sense that some countries decide, okay, we'll mitigate more so as to not give other countries an incentive to do the SRM, which these countries perceive as too risky. Next. So the last thing I want to say is I think that SRM is important, that it may be needed. It depends. Much more research has to be done on the risks. And I think that some of that research should be done by economists. In particular, what we need to do is to understand better, how changes in temperature and rainfall patterns would translate to economic losses.